Well, members, I'm back, Mr. Hyper, and I've come to take you through the chemical properties. Chemical properties of group 4 elements. Now, under chemical properties of these elements, we are going to look at the reactions. This video will cover the reactions of group 4 elements with different substances. And let's look at reactions with air. Reactions with air, let me bring it in as a question. Describe the reactions of group 4 elements with air. We have to talk about every element and how it reacts with air. Okay. Now, the component of air that is going to be involved here is particularly oxygen, not any other. So one can say reaction with describe the reactions of, or no, as one is answering, one can say maybe certain element reacts with oxygen as a component of air, or since it's the only component of air involved, one can say reacts with air. All right. So let's begin my answers. When you're describing the reactions, you have to give me the condition. Your description must have conditions of reactions, the products, and the equation. So for example, with carbon, that carbon must be strongly heated. Strongly heated carbon reacts with air to form carbon dioxide. So we shall have carbon plus oxygen form carbon dioxide. Strongly heated reacts with air to form carbon dioxide. Okay. Then still, for silicon, it will be strongly heated silicon. Strongly heated silicon reacts with air from silicon dioxide. So we shall have silicon plus oxygen forming silicon dioxide is a solid. Then still strongly heated germanium reacts with air to form germanium 4 oxide. You write the equation, germanium plus oxygen will form then we've got strongly heated tin. Reacts with air from tin oxide. So we shall have tin plus oxygen. We form tin 4 oxide. Okay. Then with lead, heated lead, it burns in air, but for it, it forms lead 2 oxide, not lead 4. Because the lead in the +4 oxidation state is unstable, meaning it can undergo decomposition. Okay, when we form lead 4 oxide, it will undergo decomposition. So we form lead 2 oxide, which is stable. The final compound should be stable. So that is where the oxidation state idea has come about. So we shall have lead plus oxygen, we form 2 lead oxide molecules. You must form a stable compound. So this is how these react with the, this is how these compounds, this is how these elements react with the air. Let's look at reactions with water. Reactions with the water. How do these elements react with water? Carbon, silicon, and germanium and tin, they don't react with water. Carbon, you have to first, if the question is describe the reactions, then you have to tell me that carbon, silicon, germanium, tin do not react with water. Actually, let's say with the cold water. They don't react with the cold water. But we have seen that they don't react with cold water. But if it is red hot carbon, red hot carbon, I'll first mark this because you've told me the conditions, the condition under what they don't react with water. So that is, they don't react with cold water. But red hot carbon slowly reacts with the steam, and this reaction is reversible. So reversible react with the steam, form carbon monoxide, and hydrogen gas. The mixture of these two gases is what we call the water gas. So when carbon reacts with the steam, steam is water in gaseous form, we form carbon monoxide reversibly. We form carbon monoxide gas and hydrogen gas. You have to be specific with which carbon and which type of water. Reacts reversibly with the steam to form carbon monoxide. I told you that conditions can need to be marked and the products and the equation on a good day, or 1 mark on equation. Then red hot silicon. Red hot silicon reacts with steam to form silicon 4 oxide and hydrogen gas. So we shall have silicon plus steam giving us silicon dioxide or silicon oxide, solid, then plus, of course, hydrogen gas. Germanium at any condition does not react with the water. But red hot tin reacts with steam from tin for oxide and hydrogen. So it will be tin plus steam to form tin for oxide plus hydrogen gas. These numbers of inorganic chemistry, you can really understand them by practice. The more you practice the things, the more easy they become. Okay, the more you practice them, the more easy they become. Because here it's a matter of knowing under what conditions. I'm going to do you a summary at the end. Then for lead, lead must react with only soft water containing dissolved oxygen. Okay, so lead for it reacts with soft water which contains dissolved oxygen and we form a solid product of red hydroxide. You have lead plus water containing dissolved oxygen form lead to hydroxide. This is how we do it. Now we found out that for reactions with water, of course, we've got carbon, we've got silicon, we've got, that is in summary, I'm doing a summary, we've got silicon, we've got germanium, we've got tin and lead. Carbon, just carbon, doesn't react with water. But red hot carbon reacts with steam to form carbon monoxide, and the reaction is reversible. So we form carbon monoxide and hydrogen. This silicon, it must be red hot. And it also reacts with steam. Just that's how you get them. Germanium does not at any condition. Tin must be red hot. Okay. Tin must be red hot. And reacts with tin must be red hot and reacts with the steam too. Lead just reacts with the soft water containing dissolved oxygen. So you need to know under what conditions and what products do I form. So that is the reactions. Those are the reactions with oxygen, with water. Then from there, they can tell you to describe now with the dilute acids and concentrated acids. Describe how group 4 elements react with one dilute acids, two concentrated acids. Now, to begin with, dilute acids when we talk about dilute acids, we've got a series of these dilute acids. We've got dilute hydrochloric acid, we've got sulfuric acid, we've got nitric acids. So when you look at dilute acids, if we are to begin with the hydrochloric acid, with the dilute hydrochloric acid, let first note for me that carbon, silicon, germanium, these ones, they do not react with the dilute hydrochloric acid. Okay? They do not react with the dilute hydrochloric acid. But tin, now it means that tin and lead do. But let's see. Tin reacts with cold dilute hydrochloric acid to form tin 2 chloride and hydrogen gas. You have said that tin reacts with the hydrochloric acid to form tin 2 chloride and the hydrogen gas. All right. Lead, now there is lead. Lead reacts but slowly because you form lead 2 chloride, which is insoluble, and the reaction soon stops. So lead reacts slowly with dilute hydrochloric acid, and the reaction stops. Due to formation of insoluble lead 2 chloride. Formation of insoluble lead 2 chloride. Since the reaction soon stops, or since the reaction stops, we do not need to write the equation there. So that is with the dilute hydrochloric acid. Then with the dilute sulfuric acid. With dilute sulfuric acid, for dilute sulfuric acid, we need to note that still carbon, silicon, germanium, these ones, carbon, silicon, germanium, they do not react with the dilute sulfuric acid. Even tin, carbon, silicon, germanium, tin do not react with the dilute sulfuric acid. But lead slowly reacts with it. So reacts with dilute sulfuric acid, and the reaction stops. Due to formation of insoluble lead to sulfate. Insoluble lead to sulfate. That is it. That is what I can talk about dilute sulfuric acid. Let's look at dilute nitric acid. With dilute nitric acid, you need to first note that carbon, silicon, germanium do not react with dilute nitric acid. Do not react with dilute nitric acid. But for lead and tin, they do. We are going to see how. It would mean that when the acid is called dilute, because now if the other three do not react, it means tin and lead do. So let's talk about tin and lead. Called dilute nitric acid. Oxidizes tin to tin 2 nitrate, then itself gets reduced to ammonium nitrate and water. Some stubborn reaction, which is also undergone by iron and zinc. So we have said that tin reacts with cold dilute nitric acid, ten molecules to form tin 2 nitrate, and itself gets reduced to ammonium nitrate. And water. So one can write still an ionic equation. And this ionic equation is the tin plus hydrogen ions forming tin 2 ions. You have to write this equation very well balanced, plus ammonium ion. Of course, the nitrate will cancel with this nitrate. Then, of course, plus 3 molecules of water. That is how it reacts. Then, for the case of lead, for it to react, it has to react with dilute or moderately concentrated or half concentrated nitric acid. Okay, so this acid oxidizes lead to lead to nitrate, and itself is oxidized, is reduced. Itself reduced to nitrogen monoxide, and water. So we have said that lead, we shall have 3 lead atoms plus nitric acid. We form lead to nitrate plus nitrogen monoxide and water. Ionic equation, you can write lead plus hydrogen ions, yeah, plus nitrate ions, we form, these are 2 nitrate ions, 3 lead, these are supposed to be 8 hydrogen ions, 2 nitrate ions. So from 3 lead 2 ions, nitrogen monoxide, and water. That is what we form, because in an ionic equation, gases and liquids do not ionize. So before we go to concentrated acids, there are some other acids with which these elements react. For example, silicon. Silicon is the only element that reacts with the hydrofluoric acid. Reacts with the hydrofluoric acid and when it does so, we form hexafluorosilicic. Hexafluorosilicic acid, hexafluorosilicic acid, and hydrogen. So we're having silicon solid plus hydrogen fluoride, sorry, hydrofluoric acid, we form hexafluorosilicic. Hexafluoro, hexa meaning the fluorine atom is supposed to be 6. Hexafluorosilicic acid and hydrogen gas. Also, lead can react with the ethanoic acid. These are reactions with other acids. Lead reacts with the ethanoic acid. And that reaction takes place in presence of air. In presence of oxygen or air to form lead to ethanoate and water. So we have lead plus ethanoic acid in presence of oxygen to form lead to ethanoate and water. So from there, we can go to concentrated acids. So you should make your own summary and you see how they do. Concentrated acids react with the variety of them. And let's see how these reactions are with concentrated acids. Of course, concentrated acids we are also going to look at first with the conc hydrochloric acid. With conc hydrochloric acid. If you begin with hydrochloric acid, carbon, silicon, germanium do not react with the conc hydrochloric acid. These ones, they do not react with the conc hydrochloric acid. But tin reacts vigorously. When you're writing for us, don't write SN, write tin. Reacts vigorously with the hot conc hydrochloric acid, form tin 2 chloride and hydrogen to form tin 2 chloride and hydrogen. So we shall have tin solid plus hot conc hydrochloric acid shall form tin 2 chloride and hydrogen gas. Also, lead can react with the boiling hydrochloric acid, boiling concentrated hydrochloric acid, form lead 2 chloride and hydrogen. Okay, so also now lead reacts with the boiling conc hydrochloric acid to form lead 2 chloride and hydrogen. So looking at that, it is lead solid plus boiling conc hydrochloric acid aqueous form lead 2 chloride and hydrogen gas. That was the concentrated hydrochloric acid. 2, when we look at concentrated sulfuric acid, this one is a strong oxidizing agent, and most of its reactions are going to be with the compounds which it with the compounds that it does what? That it oxidizes. For example, we are going to say that yeah, let's begin with carbon. Hot conc sulfuric acid oxidizes carbon dioxide and itself reduced to sulfur dioxide and water. When you're writing these words, just sulfur dioxide, those are 2 words, and water. So equation, we have carbon solid plus conc sulfuric acid. We shall form carbon dioxide gas, and it sort of will be reduced to sulfur dioxide gas and water liquid. Silicon, that was carbon, silicon and germanium, they do not react with concentrated sulfuric acid, but tin is oxidized. So hot conc sulfuric acid, being an oxidizing agent, oxidizes tin to tin phosphate, and itself reduced to sulfur dioxide and water. Sulfur dioxide and water. What does it mean? We have tin solid. It is oxidized by conch sulfuric acid. And we say that we form tin phosphorate. If it is tin phosphorate, mean that the valence of tin is 4 and the sulfate is 2. So shall have tin phosphorate as this. And itself is reduced to sulfur dioxide and water. Because we need to know the aspect of oxidizing agents and reducing agents. An oxidizing agent is reduced. So since sulfuric acid is an oxidizing agent, at the end of the reaction, it is reduced to sulfur dioxide and water. So that is tin. Then lead, hot concentrated. You have to write the whole word. Hot concentrated sulfuric acid oxidizes. Lead to sulfate and itself reduced to sulfur dioxide and water. So we shall have lead plus conch sulfuric acid shall form lead to sulfate, and so forth be reduced to sulfur dioxide and water. The best thing here is to learn how to balance these equations and they stick into your head. Now it means that for this reaction with conch sulfuric acid, it is carbon, tin, and lead that undergo it. So when they said describe the reaction with describe the reactions of group 4 elements with dilute acids, talk about dilute acids. With each element, if they say with concentrated acids, talk about acid. But if they say acids just, you have to talk about dilute and concentrated. And you have to give, when the question is just describe, you have to give us the conditions in the reaction, products formed, and the equation. As simple as that. Let's go to conch nitric acid. With the conch nitric acid, with the conch nitric acid. Okay. Let's begin with the carbon. Hot, it is also an oxidizing agent. Hot conch nitric acid oxidizes carbon to carbon dioxide. Those are two words when you're writing words, and itself. Reduced to nitrogen dioxide, and water. I'm using formulas because of maybe time and the work we have to cover, but make sure you use words. So equation, we have carbon plus nitric acid, hot conch nitric acid. We say that it oxidizes carbon to carbon dioxide, and itself gets reduced to nitrogen dioxide and water. Then silicon, now that is carbon, silicon does not. react with the conch nitric acid. But when we go to germanium, hot conch nitric acid, it oxidizes germanium or germanium to germanium 4 oxide, to germanium 4 oxide. Being an oxidizing agent, itself is reduced to nitrogen dioxide and water. Equation: germanium solid plus conch nitric acid from germanium 4 oxide, and itself is reduced to nitrogen dioxide and water. So it's a matter of knowing which ones react, which ones do not react. Under what condition it must be hot conch to form what? Germanium 4 oxide and nitrogen dioxide and water. Still, hot conch nitric acid, hot conch nitric acid oxidizes tin, oxidizes tin to tin 4 oxide and itself reduced to nitrogen dioxide and water. And that equation can be written the same balancing scheme. So we have tin plus nitric acid molecules form nitrogen dioxide and water. Lead hot conch nitric acid, hot conch nitric acid oxidizes lead to nitrate and itself reduced to nitrogen dioxide and water. How do we write this equation? We shall have lead plus nitric acid shall form lead to nitrate, and itself would be reduced to, you will fetch all your marks. And the thing is easy to learn. It's a matter of knowing which one is reduced to what. Those, apart from lead, others are reduced, oxidized to their dioxides. Throughout we form nitrogen dioxide gas. And still throughout water. The balancing points on nitrogen dioxide gas are equal, 4, 4, 4. Water, 2, 2, 2. Nitric acid, 4, 4, 4. You see? So it's a matter of knowing 4, 4, 2, 4, 4, 2. Very simple. So it is always easy to get all the marks on an inorganic chemistry question. Very, very, very easy. Quite easy. Quite easy to get all the marks. Okay. So now those are the reactions with acids. Now, with alkalis, because I want to record all the reactions of these elements in one video, so let's look what with alkalis. Reactions with dilute and concentrated sodium hydroxide. I've specified an alkali, but even if they say potassium hydroxide, they are the same. Let's begin with dilute. We dilute alkalis, okay? We dilute sodium hydroxide. I'll summarize this for you. Carbon does not react with either dilute or concentrated sodium hydroxide solution. So to begin with, carbon does not react with dilute and sodium hydroxide solution. That is carbon. Silicon reacts with both dilute and hot conc sodium hydroxide to form sodium silicate. We form sodium silicate and hydrogen gas equation. We have silicon solid plus sodium hydroxide solution in presence of water. We form sodium silicate. And hydrogen gas. How do we write the equation? We have the ionic equation. You can say O silicon plus sodium hydroxide plus water, you form a silicate ion and hydrogen gas. As simple as that. Okay. Then let me make it general. Reactions with the dilute and cold. Okay, so silicon is the one that reacts with both dilute and cold. Carbon does not react with dilute and conc. Then germanium reacts with the hot conc sodium hydroxide to form, we form a sodium jammet. We form a sodium jammet 4 and hydrogen gas. With germanium, we form a sodium jammet 4. But when it does reacted with hot concentrated, it does not react with cold. How do you write the equation? You have germanium plus sodium hydroxide plus water. You form sodium jammet 4. Sodium jammet 4, we write it like this, sodium gamete 4 and hydrogen gas. How do we write an ionic equation? You have germanium solid plus hydroxide aqueous plus water. We shall form sodium gamete 4 plus hydrogen gas. Or you can write germanium solid plus sodium hydroxide, excess water. Here I've used 4 molecules of water, and now still we form sodium gamete and hydrogen. You can write this ionically as germanium plus hydroxide ions plus water molecules to form. Now for this case, we shall have a gamete of ours written as this is a gamete ion, gamete 4 ion, aqueous, and hydrogen gas. So out of these ones, you can pick any equation and use it when it comes to the reactions of germanium. Tin reacts the same way as germanium, but with the also concentrated. Okay, so tin reacts with the hot conch sodium hydroxide to form sodium stannate. For this, we form sodium stannate 4 and hydrogen gas. I told you that one will mark what it reacts with under product. Hot concentrated sodium hydroxide forms sodium stannate 4. Equations. You can write tin reacting with sodium hydroxide and water. You'll form sodium stannate 4 and hydrogen. Or you can write the ionic form of this plus 2 hydroxide ions plus water. You form SnO3 2 minus and 2 hydrogen gas. Or can write tin plus sodium hydroxide plus 4 molecules of water. Still, you're going to form a stannate. You are going to form Na2 SnOH6 and hydrogen gas. Or still you can form with OH and 4 molecules of water, because water does not ionize. You form SnOH6 2 minus and 2 molecules of hydrogen. Any of those ones will earn you a mark. Now, that was tin. With lead, with lead, it reacts with hot also, hot conc sodium hydroxide to form sodium plumbate, and from sodium plumbate 2, not 4, sodium plumbate 2, and automatically hydrogen gas. Equations: you can have lead solid plus 2 sodium hydroxide without water. You'll form a plumbate 2 and hydrogen, or you can have lead plus sodium hydroxide, sorry for this equation. Sorry for this equation. Let me repeat the first one because it was supposed not to be ionic here. So lead plus sodium hydroxide you form a plumbate, sodium plumbate 2. Okay, yeah. Sodium plumbate 2 and hydrogen gas. Or you can write the ionic form of this as lead solid 2OH ions to form PbO2 minus aqueous and then hydrogen gas. Or you can write it when it's reacting with water, in presence of water. So you'll have lead plus 2 sodium hydroxide plus water to form sodium plumbate and hydrogen gas, or lead plus 2OH plus water, you form a plumbate PbOH 4 minus 2 minus rather plus hydrogen gas. So still any of those can work. Now we are left to talking about the reactions with chlorine and then sulfur. Okay, reactions with chlorine. They can tell to describe the reactions of group 4 elements with chlorine. With chlorine, of course, you have to talk about each. Carbon does not react with chlorine. 2, the other ones have to react, but when they are heated. Heated silicon reacts with which kind of chlorine? Dry chlorine to form what? Silicon tetrachloride. Form silicon tetrachloride. So we shall mark, and then you write the equation. Silicon plus chlorine, how many? 2. We form silicon tetrachloride. This is a liquid. Heated germanium reacts with the dry chlorine to form what? Germanium 4 chloride. From germanium 4 chloride. You write the equation. Ge plus Cl2 gas, you form GeCl4. It's a liquid. Then we've got what we call heated tin reacts with also dry chlorine to form tin 4 chloride. Yeah. Tin 4 chloride. You have to write the word. So we shall have tin plus 2 chlorine molecules. We are forming tin 4 chloride. Liquid. That is tin. For lead, it must be also heated. Heated lead reacts with, when you're describing, you have to write words. Heated lead reacts with dry chlorine. Now for lead, we don't form lead 4 chloride because lead 4 chloride is unstable. It will undergo decomposition. Instead, we shall form lead 2 chloride. And lead 2 chloride is not a liquid but a solid. That is why students get it wrong. So for lead, it's a solid which reacts with chlorine gas to form lead 2 chloride solid. You've known why we are forming the chlorides of the positive oxidation state, and for lead we are forming plus oxidation state. We say that for plus oxidation state, with lead it is more stable compared to plus oxidation states. Okay, I'm concluding with this reaction, and this is the reaction of group 4 elements with the sulfur. Reactions with the sulfur. All of them reacts with sulfur. Okay, but they must be heated. Heated carbon, we begin with the carbon, reacts with the vapor of sulfur. That's why I call it sulfur vapor, to form carbon disulfide. So you can write the equation: carbon plus sulfur vapor, you form carbon disulfide, and it is in liquid form. Heated silicon reacts with sulfur vapor to form silicon 4 sulfide. Form silicon 4 sulfide. Equation: silicon plus sulfur vapor, we form silicon 4 sulfide. This is a solid. It is only carbon disulfide that is a liquid. Others we form solids. Heated germanium reacts with the sulfur vapor, and here we form germanium 4 sulfide. Germanium 4 sulfide. So you will have germanium plus sulfur vapor, you form germanium 4 sulfide. Even heated tin reacts with sulfur vapor to form tin 2 sulfide. For tin, we form tin 2 sulfide. Because as you go down, the sulfides, the oxidation state of the +4 decreases. So we shall have tin plus sulfur vapor, we form tin 2 sulfide. Then still, heated lead reacts with sulfur vapor to form lead to sulfide. So you'll have lead plus sulfur vapor to form lead to sulfide. In our next video, we shall record the compounds of group 4 elements and we shall begin with the dioxide. See you.